We're going to begin this lesson by reviewing a few things that we should know by this point in this chapter. So the first warm-up question is asking you to complete the square to express this quadratic in its vertex form. Number 2 is asking you to solve, in other words, get what x is equal to by isolating, so that's the SAM-dub there. And then number 3 is solving by factoring. All right, so take a few minutes, try those out, and then you can check your answers here. Okay, so for the very first one, the first step of completing the square would be to common factor the a value. So a is -3. That a value comes out of the first two terms only. And that gives you x squared minus 8x. And then you just carry the plus 27 along. And then from there, we're going to take half of that middle term, or half of the -8. Half of -8 will give us 4, and then 4 squared is 16. We're going to add that number, 16, and subtract that number to keep it an equivalent expression to the line that's above it. And then we're going to kick the minus 16 out of the bracket. It doesn't belong as part of that perfect square. And to kick it out, we're going to multiply it by the -3. So we're keeping the plus 16 in the bracket, but we're going to expand the -3 with the -16. That gives us a plus 48. And then we have our plus 27. And now we can factor that perfect square that we made. So square root the first, square root the last, and take the sign from the middle, all to the exponent of 2. And we're going to collect the two like terms on the end. And I believe that gives us a 75. All right, so now we have the vertex form. If I needed to know the vertex for this will be at +4, because we switched the sign on that, and +75, and that parabola is opening down. All right, so if I wanted to do a sketch of this, this is more than what I had asked, but if I did a sketch, it would be at 475, opening down. We're going to look something like that. And you can see there would be two x-intercepts for that parabola. So let's solve this for isolating for x. Now I want to draw your attention to this for a second. Do you notice that the equation I have here, oh dear, there we go. This equation, or that part of it, is exactly what is right here. And I did that on purpose because we're going to solve this by isolating for x. We're going to undo the plus 75 first by subtracting 75 from both sides. So I'm going to keep -3 times x minus 4 all squared. That's going to equal -75 now. So I undid the plus 75 by subtracting 75 from both sides. And now I'm going to divide both sides by -3. Divide by -3. That will get rid of that. And then -75 divided by -3 would be 25. So we get x minus 4 all squared equals 25. And then we're going to undo the exponent 2 by square rooting. And when we square root, we always have two answers, a positive answer and a negative answer. So that leaves us with an x minus 4 still on the left side, and that's going to equal positive or -5. And then to get x by itself, we're going to add 4 to both sides of that, and that gives us x equaling +5, or 5 plus 4, or x is equal to -5 plus 4. So that gives us, that's supposed to be a plus there, that gives us, oh goodness, 9 or -1. So what I have on my graph then is that my 0 would be at +9 or at -1. So that's -1, this is +9, and we said our vertex was at 4, 75. Now I also know what my y-intercept is from up here. The y-intercept from standard form is there. This would be at +27. Okay, so it's just a sketch, so I'm just labeling the coordinates that I know on my sketch, and that way I don't need to have an actual grid on there if I had to sketch it. All right. Number 3a, solve by factoring. I'm looking for two numbers. First of all, common factor if you can, but there isn't a common factor for this one. So I'm looking for two numbers that will add to -1 and multiply to -42. And that 42 comes from 2 times -21. And that would be -7 and +6. So I'm going to decompose. We're going to have our 2x squared. I'm going to put the 6 with the 2. Plus 6x minus 7x minus 21 equals 0. I'm going to pair these up for common factors. 2x is common to both of the first two terms here. Gives you an x plus 3. A minus 7 can be taken out of the second pair of terms. And that cooks that up to be an x plus 3 as a common factor, multiplying a 2x minus 7. And that gives us either x equals negative 3, so x plus 3 equals 0, subtract 3 from both sides, x equals negative 3. Or 2x minus 7 equals 0. I'm going to add 7 to both sides, 2x equals 7. Divide both sides by 2, x equals 7 over 2, or 3.5. All right, last one here. I'm looking for two numbers. There's no common factor. Look for two numbers that will add to negative 6 and multiplies to 2. The only thing that's going to multiply to 2 are 1 and 2, but they definitely don't add to negative 6. So this one is one that doesn't factor. Now, if we were to put that into Desmos, though, we would see that there are some x-intercepts. If we put y equals and this function into Desmos, we would see there are x-intercepts there. But the question is, how do we get them? So let's take a look at this next part here. Not all quadratic equations in standard form can be solved by factoring, as we just found out. We could express the equation in its vertex form and then isolate for x. So here I've rewritten that example for part B, and we are going to do just that. We're going to complete the square on this to write it in vertex form. So I don't have to worry about taking the a value off of the x because the a value is just a 1 there. I'm going to take half of that negative 6, which is 3, and then 3 squared is 9. I'm going to add the 9 and subtract the 9, which is, we still have our plus 2 there. I forgot about plus 2 equals 0. These first three terms form that perfect square. When I factor it, square root the first, square root the last, take the sign from the middle, all to the exponent of 2, and collect the like terms on the end. Now at this point, I can isolate because I have that vertex form. Now we don't have to follow this process. We're going to learn another way to do this that expedites this process, makes it quicker. I'm going to square root both sides. And when I do, I get two answers. There's going to be positive square root 7 and negative square root 7. I'm going to leave that in its root form. I'm not going to take it to its decimal. That's called leaving it in exact form. And then I'm going to add 3 to both sides. So we have plus or minus the square root of 7 plus 3. If I want the decimal values, we have our root 7 plus 3. We can put that in the calculator. But if you're just being asked for exact values, you're going to just leave it with the square root of 7. Okay, so you can put those in your calculator. I'll do that right now and you can check. So when I did that, I got about 5.65 and about 0.35. And those are just rounded answers, so that's why there's a dot above the equal sign. Okay, so there's this thing called this quadratic formula that we're going to learn that is an easier or quicker way to do what we just did right there, right now. And the quadratic formula goes like this. Let me write it in here. It goes x equals negative b plus or minus square root b squared minus 4ac all divided by 2a. And there is a video that I will post to Google Classroom that plays this over and over again, and it has this crazy dancing baby on it, and it's just wild, but wild in a crazy kind of way. But it will help you remember it if you can remember the song. It'll help you remember the quadratic formula. All right, as far as where to get those values from, the a is what we're multiplying x squared by. So for this equation up here, a is just equal to 1. The b is the coefficient of the x term, which is negative 6, and the c is the constant term, which is positive 2. What we're going to do here is now say that our x would have to equal negative and then b, which is negative 6. So it's going to be negative, negative 6 plus or minus square root b, which is negative 6 squared minus 4ac. I can't believe I'm singing this on your video. All divided by 2a, permanently endangering your brain with my music. All right, minus minus will be plus 6 plus or minus the square root of 6 squared is 36 minus 4 times 2 is 8. Or you can just punch that all in your calculator. You're going to get the square root of 28, all divided by 2. So our x will equal 6 plus the square root of 28. You want to hit equals there and then divide by 2. Make sure you hit equals on that numerator first before you divide by 2, or you're going to get an incorrect answer. And sometimes even grade 12s, calculus kids even have trouble with that sometimes. So don't forget to hit equals before you divide by 2. So there's my 5.65. And then we have 6 minus the square root of 28 divided by 2. And that's going to give us 0.35. So this is the quadratic formula. I'm going to go through some more examples on the next video that will help you with your homework. And I also, for those of you who are interested, I have a separate video on the development of the quadratic formula, of how we're using the steps that we did with the numerical example here to actually come up with a quadratic formula. So those going into 3, you should watch that video and try to follow it along if you can.